session of the day. Previously, we were talking with Webb Pinner, who is the primary author on OpenVDM. You also heard Webb talk a little bit about OpenRVDAS, and we have with us David Pablo-Cohn, who's the primary author of OpenRVDAS. So whereas Webb talked about OpenVDM not dealing with the zeros and ones and not dealing with the sensor aggregation, this, on the other hand, is one of the great specialties of OpenRVDAS. And as we did talk about earlier, OpenRVDAS is being increasingly used by quite a number of organizations as that engine of activity, trying to draw together all of those different pieces of the puzzle in order to bring them together so that they can be delivered onwards. David was talking a little bit earlier, wanting to know people's backgrounds. We do have a range of backgrounds within the room, some programming specialists, some non-programming specialists. I did talk with people during the break as well, and but people were saying, yes, this is actually good introduction, even for non-specialists, to get an understanding of the capabilities and how it could eventually be delivered onwards. So, but at the very least, David, I did talk about earlier, treat this as a dinner table conversation, you know, shared problems, shared solutions, and trying to build up the community. So we got the thumbs up. So David, I'll turn over to you. And again, thank you very much for participating in this.
Oh, sure. For organizing this here. I'm going so you're going to get to the shared messy screen here. And
that's all right.
Do a slideshow.
We do see it.
Come on, slideshow. And
perfect. We've got it.
Away. Okay, excellent. So as I was telling Tess, the question was whether to caffeinate or not to. The sun has finally come up here. I think we've got the world, the globe girded here between me and Tess. Let's see. I'm an engineer, so I also have an outline. This is what I was figuring would be useful things to cover. First, figure out a background on an introduction to RVDAS, then kind of do it once around the room, figure out who's using OpenRVDAS for what, have any war stories, interesting deployments. I can talk a little bit about recent features we've pushed out, and is Ella in the room? Because one of the recent features is this awesome thing that we've gotten from Ella, who's contributed, and we've had some other recent contributions. Then I'd love to kind of go into probably the meat of what are the challenges of folks who are trying to use it, what's breaking, and then save time for roadmap and wish list of where I think we should be going from there. So let's see, what's the consensus on an OpenRVDAS background? I have a slide deck from a previous RV Tech presentation that I can blow through, which is sort of an introduction, and these are the pieces of it. Should I do that, or are folks comfortable with the concept?
I think it would be useful for you to go through it. I think that there may be some people who want it from the ground up. So just whatever you've got, I think that would work.
Okay, so let's try to figure this out. How I want to turn this into a slideshow. I am not a Keynote user. View slideshow, enter full screen. Oh, come on.
Oh, enter full screen. Yeah, there it is.
Well, it's still giving me the editing.
There's the play button, Pablo, in the top.
Play. There we go. Thank you, Webb. Okay. OpenRVDAS, I like saying, it's slightly misnamed. It's not so much a data acquisition system as a framework for snapping together data acquisition systems. The idea is, well, first, motivation. When I started this, this was on the NBP, we were running a 25-year-old copy of something that had been modified beyond recognition. It was straight C wrapped in a Perl script, wrapped in a bash shell that restarted it every 48 hours, because otherwise things crashed mysteriously. Everyone's got their own system, massive duplication of effort. There's no common pool of expertise, like as Webb was saying. If you have a problem, if your ship is the only ship that's running this system, there's no one you can go to for help. If there are common pieces of code, you're going to get a community where ships will say, "Oh yeah, we saw that." Grounding wire. So MIT license. As I said before, it's a framework, not a system. Different, systems requirements change. Good framework lets you put together what you want. The way I look at this, I often describe it as a bunch of Lego pieces that can get snapped together to build the system you want. The basic components are readers, transforms, and writers. Oh, there we go. And basic ideas, for example, you read from a serial port, you transform it by putting a timestamp on it, putting an instrument ID on it, and then you write it to a file or wherever. Requirements aren't that tough. Python 3.6 or above, pretty much all POSIX compliant systems. Installation scripts for all of the Linux variants runs manually on Windows. You can do manual install on Windows. I know two Windows installations out there. Actually, I'm going to step away from this for the presentation for just a moment to do a show and tell, if I can. Just because maybe I can. Yeah. Maybe I'm not being well. We've got it running on that. In March, I went down to Palmer Station carrying the precious of a couple of Raspberry Pis that we replaced. Their data acquisition system now is running on a little Raspberry Pi 4. I've got it running. I've got a couple of them running on Pi Zeros. I can do a show and tell a little bit later on with that. Let's see. So outlines. This is the outline within the outline. So in the background, build loggers out of these components. Then we're talking about how you control the loggers that you've built, and then what you can do with the data you're getting from there. As I've said, the loggers are these basic units of data acquisition, and they're made up of readers, transforms, and writers. So here's a simple example of a few components. You read the data from your machine, you timestamp it, you write it to a file, but you also prefix it with the logger ID or the instrument ID and send it out on UDP. Mess of different types of readers. You can read from serial, network, file bases. You can also crazy numbers of transforms, and you can write it out to all sorts of improbable things. There are a few different ways you can combine them. If you really want to be optimized, if you really want full control, you can actually write Python code to combine these things. That top box there, the blue one, that is complete logger. That's runnable Python code where you define your reader. It's a serial reader reading from port TTYS1. Transform, which is going to timestamp it, and you create a log, tell it where it's going to write it, and you just loop through. The reader has one method, which is read. Transform has one method, which is transform, and the writer has one method, which is, wait for it, write. From the command line, there is a script called the listener, which aggregates a whole mess of the readers, transforms, and writers, and allows you to basically run a logger, define a logger from the command line. So you can see from the command line arguments is basically define a serial reader that reads from TTF1, a timestamp transform, a prefix transform, and there's a log file writer and a network writer. Actually, 3 writers, also writes it out to the database. For more complicated loggers, things that do more involved transforms or send the data multiple ways, it's easy, robust. And I've got duplicate slides. Okay, we're going to step forward here. So you create a configuration file like the thing below, and then you run the listeners, run the configuration in the file. So that is basically how you create a logger. And the logger is something that will read from one instrument typically, and it'll process the data and write it somewhere. Now, typically on a ship, you're going to have a bunch of sensors and a bunch of loggers. So you need something surrounding them to run the loggers and control the loggers. And there's this thing we have called the logger manager. And logger manager allows you to define modes. So basically, generally, when you're in some phase of operation of the ship, you want loggers in certain configurations. So like you want to define when you're in port, your Knudsen isn't going to be running. So you don't want that writing. Your metadata, you're still going to want to gather that. So you want those to be running. So basically for each mode of the cruise, you'd like to have this logger in this state, or this logger in this configuration, this other logger in this other configuration. The logger manager allows you to define sets of configurations and allows you to switch between them. And the logger manager also monitors the loggers, and if something dies, it'll restart it, it'll alert you. Now, the architecture of the logger manager is not something you interact with directly. And this is, my previous life, I was a software architect. I kind of spent a lot of time thinking about how you build stuff that is modular, scalable, and robust. And deciding was the way everything is controlled is through a database. Basically, the logger have some user interface, and you put in the database, this is the state that I want my system to be in. The logger manager reads the database, makes it so with the loggers. If something is not the way it should be, it writes that feedback into the database that you can get back. This allows you to have a bunch of different user interfaces. All you have to do is have an API that lets you write to and read from the database. So yeah, you can have your favorite front end. So, there's a command line front end. So you can run the, run the API, and you can say, load this configuration. What are the modes? Set the active mode to underway. What are the loggers? Get the configurations, etc. There's a Django-based GUI, which allows you to do the point and click. There's also, as of about 2 weeks ago, there's now a Lite-based JavaScript GUI, which I can show you a demo of. That was done by Kevin Pedigo from the U.S. Antarctic program. And so that's running, controlling the loggers. And so basically, this is, that just describes the process of getting data in and throwing it to disk or throwing it somewhere. And a lot of the stuff in these remaining slides are things that we are actually now outsourcing to existing software. So we've built native HighCharts-based widgets that we can activate from and display from within OpenRVDAS. And let me pop out of here and see if I can actually get to Uh, go to, nope, let's find a different one. That, yeah, okay. So here is the Django-based OpenRVDAS GUI. You know, we can pop this open. We can see. You know, we can change the mode. Have it right to. You can see all of the individual loggers are going to update. We can turn an individual logger off if we want. We can actually look at what the configuration looks like. But, you know, for example, I'm going to turn that logger off for some reason and then back on. And the original native widgets that we created, so these are widgets running within the system. And you can do some nice things with this. So for example, I'm going to turn the data off. And notice, first of all, that things stop updating, and then these widgets notice that they haven't been updated. And first they turn yellow to warn us that it's been 15 seconds or so, and then they turn red, and these are all configurable within the widget. So, you know, soon after creating all of this stuff, we discovered that we reinvented the wheel and the horse and the cart and the automobile. And Webb and I were introduced to Influx and Grafana. And that's, yep, for secret passwords there. Oh, come on. Of course, somebody is calling me right now. So we can, so this is the Influx data explorer. You can look at, you know, we can just generate graphs as we want here. We can zoom in on them, etc. And going into Influx in detail is way beyond the scope of this background, but Influx is a real-time database, time series database. And using Influx, you can build dashboards like this that get displayed by Grafana, which give you all sorts of lovely features. So we're encouraging people nowadays, rather than using the native OpenRVDAS widgets to basically for their database storage, Influx for their graphing, to use Grafana. So that's just one sample. Here's another a sample Nathaniel B. Palmer all-in-one dash. And oh yes, I was going to play show and tell. So this is these are the computers for the old data system for the NBP, the Nathaniel B. Palmer. And each display, closed circuit TV, was originally its own separate computer. And the big innovation was we brought it down to each individual display was its own Raspberry Pi. Now, a single Raspberry Pi can run as many displays as you want. This is the Pi running the Palmer Station water wall right now. That's live data coming off. And yep. And this is running OpenRVDAS right now. It's actually sitting right outside my window. And this is this is these are the environmentals at my house right now. You can see I fired the wood stove up at about 4:30, and temperature came way down overnight, etc. So so the Grafana Influx OpenRVDAS combination is really lightweight and really flexible. Let me show you one more UI, which was this is the new SQLite based UI. This was coded up in about a week or so by Kevin Pedigo. So just the fact that somebody who isn't a core architect can say, hey, I want to create my own front end to this system and do it. I think, I'm going to brag a little. I think that speaks well of the system. So let me see where I think that was. I'm going to describe just a few more things that you can do with OpenRVDAS. Some of the transforms, because of this Lego brick setup, you can do some non-intuitive things. So you can create derived data. For example, your relative wind data are getting read and stored and sent out onto the network. And in order to get true winds, of course, you need your relative winds. You need the ship course, the ship heading, the ship's speed over ground. Let's see, I think that plus relative wind will give you the true wind. And you can do that in OpenRVDAS. There is a true winds transform, which reads data out of OpenRVDAS, computes the true winds and writes it right back into the stream so that the true wind courses through the stream looking just like the original data. You can do some interesting quality control stuff on the fly. There's a thing called a QC filter transform. So normally a transform, you think you hand it a record, it somehow transforms the record and it spits it out. The QC transform, you hand it a record, and what it does is it looks at certain values. It says, is there a winch tension in this record? If there isn't, it doesn't output anything. If there is a winch tension, it says, is the winch tension between minus 150 and 10,000? If it is, it doesn't output anything. Only if there is a winch tension record that is out of the bounds that you have specified does it output something. And it will, and in this case, it outputs an alert. What do you do with that alert? You send it to an alert writer and a log file writer, and you send it to a log file writer sends it to something called winch errors. So you can basically cobble these transforms together to do some non-intuitive things. Here's another strange one. This is called a timeout writer. And nope. I just realized a typo on this. And a writer is something you hand a record to it. And you don't, all it does is it takes a record and does something with it. The intuition is that it will write it to a file. A timeout writer, you hand it records, and as long as you hand it a record at least this one, because timeout is every 60 seconds, as long as you hand it out, as long as you write to it at least once every 60 seconds, it doesn't do anything. If 60 seconds go by without being written to, it says, I haven't received data in over 60 seconds, and it writes out an error message. These are just examples of, I'm not saying that these are recommended practices. A lot of this stuff can be done just as well, and actually more cleanly inside Influx. Influx is a very sophisticated data package. These are meant to show that the simple reader transform writer combinations can be snapped together to do a fairly elaborate set of processing. And then these, if there is not if there is some device, if you want to read from your hovercraft, and there isn't a hovercraft reader, it's fairly straightforward to write a hovercraft reader. If there's a transform you want, it's fairly easy to create, that custom transform. And OpenRVDAS allows you to fairly straightforwardly just say, here's my new transform that I've written. It's over here. Pull it into the system and use it. There's another smoothing. There's the display widgets. We've already talked about those. Yeah. That I'm going to declare is the end of the background. And so let's pause there because I've been sort of monologuing. Folks have questions on background history of OpenRVDAS they'd like to dive into.
Thank you, David. Do we have any questions from the floor about the general functioning of OpenRVDAS? I know that I am quite, I have been well aware of OpenRVDAS for a while, but that was a useful introduction even for me, being able to walk through that all. So again, any questions from the floor for David? Going? Gone. I think you communicated it well, so I think that people are clear on it. But yes, we can now go to we can go ahead and continue, or we can go around the room and discuss things as well.
Yeah. So I've just put the presentation back up, so I can't actually see you. But are folks willing to do a raise of hands of and just like pipe in? Anyone want to talk a bit about what they're using OpenRVDAS for?
Yeah, we'll first of all have a show of hands, and I'll describe it. We are using OpenRVDAS. The investigator is using it, and the Schmidt Ocean Institute. So you have 3 people in the room, or I should say 3 programs that are using it. I think we have Tess with us still online, but I'll lead into Tess by starting off and saying at the Australian Antarctic Division, we very much picked up OpenRVDAS. It's used between 2 teams that we have. We have our polar technology team, who are responsible for managing the sensors on the ship, and they maintain the OpenRVDAS instance. But then we have our data officer team, and they take what is provided by OpenRVDAS, and they work a lot with both OpenVDM, but also things like InfluxDB and Grafana. So that's the pattern that we've been working with. And OpenRVDAS is the engine that ties together the broad range of sensors that we have. Tess, would you like to add anything to that? Do we still have you, Tess, or have you gone to sleep?
It's almost 3 in the morning for us. So.
Fair enough. I think she may have nodded off. I won't blame her.
I'm not seeing her in our. I don't see her on the call anymore as I look through the names.
No, I won't blame her at all. All right, so let's turn over to our investigator colleagues.
Yeah, so we're just using it basically for everything on board Investigator now. It's great. It's been a really big improvement over our last system, and allowed us to keep. We've had Grafana and Influx running for a while on the old system, but so now we're using it with OpenRVDAS. It's a lot better, and we could easily transition to the visualizations.
Yep.
Yeah, and we just have one system, but we're looking at actually implementing it on a few pies as well for some of the sensors that require a direct serial connection. So we'll have some lightweight RVDAS running in that way.
Yep. And I also do know that we've had a fair amount of work done by both Tess and Peter in terms of trying to work with names and conventions as well.
So Korean Bassin.
Hi all. Sorry. Right in the middle of that sentence, my laptop did a hard crash. I've not seen it do that in a while. And so I just got back on, and when it rebooted, it wanted to install all of the Zoom updates before it would let me join. So I missed the last about 4 minutes.
Okay, no worries. I don't mind giving a bit of a recap. So what I was saying is that we in the Australian Antarctic Division definitely use OpenRVDAS. It's split between, the responsibility is split between two teams. We have our polar technology team and our data center team. The polar technology team are responsible for the sensors and they administer OpenRVDAS. And then the data center team, the data officers, take the aggregation from OpenRVDAS. They do work with OpenVDM, but also with Influx and Grafana. So they do work with accumulating some standardization of names that come, but it's basically that's the division that we use. But we do make extensive use of it, and it's been quite successful in our application of it aboard RSV Nyuyina. So sorry, Stephanie, we'll have you go again.
That's all right. And I think I forgot to mention. That's all right. I'm Steph from the investigator with Saro, and Ella, who you mentioned before, is on my team. So you know, we've been actually trying to contribute back any changes that we've been making to the system. And yeah, we've run RVDAS on board to collect all of our underway data. And yeah, I was just saying it was a huge improvement from our last system. And but we were already using Grafana and Influx, which made that transition really easy to just replace the kind of underlying collection system and continue using the dashboards and everything.
Okay, and now we'll go back to, yes.
Hi, I'm Corinne Basson. Nice to meet you and thank you for all your work. Yeah, I've been heavily working with WebPinner on using RVDAS on Falcor 2. And also we've set up Influx and Grafana, which in of itself, being able to use that makes a lot of other QA, QC, and reporting and real-time work available, which has been great. But yeah, we use it for all of our underway systems as well as our ROV sensors and systems that scientists bring on board, adding new configurations there, and some new derived variables as well, like corrections for variables like oxygen.
Excellent. So yes, we have a broad range of use cases, and there seems to be a lot of support within the team for its use. So that's what we have around the room. We do have other institutions and organizations. I guess that without calling anyone up, they're probably using their own mix of technologies to accomplish similar ends.
Great, thanks so much. Yeah, and I wish I had discovered Influx's power earlier, because there are a lot of technologies, like there's this the alert, the various tricks to get alerts done and timeouts in QC, and especially the data smoothing. It's if you can rely on something like Influx, it's just doing it in the database simplifies things a lot, and we can just keep our OpenRVDAS down to get the data from the sensor to disk, because you want to have it on disk, because you don't trust databases. Nobody should trust any database, but you want to get it to disk and to the database, and then let the existing downstream technology take care of that. Let me try to pop back further into presentation, which is, let's see if we're going to do that one. And slideshow again. Where were we? Yeah.
Yep, it's come back up. Okay,
got it. Show and tell. So yeah, recent features. As I mentioned, Ella and Steph, you were involved also in the Jinja-based configuration creation? Or was...
Yeah.
Oh, I'm sorry, I don't have your... I apologize for not having your name there.
That's okay. Ella did the hard work of contributing it back, so I'll let her have the credit.
Okay. Well, I'll future slides, I'll swap this. So I mentioned the configuration creation, the new SQLite API and GUI. Michael Labriola in the last 2 weeks has just been like firing pull requests at me on, cleaning up the UDP and serial readers. And then there's a new WebSocket reader. I've just got a slide on each of these here. Anyone who's used OpenRVDAS knows what a god-awful nightmare these configuration files can be. Let me see if I can. So, sorry, and where is the, there we go, test. Okay, so are you seeing the code thing here?
We see your Jinja slide, but I don't think we're
okay.
seeing a
I
code
am
execution.
going to switch the sharing to, I'm going to share my desktop, although I worry that was what, okay.
Yeah, we do see an IDE type environment.
Yeah, so this is for those of you who haven't used OpenRVDAS. This is the point where you should be afraid. This is one of the weak points, which is how I described these individual configurations, how they're nice, small, and concise. Well, each sensor will have a bunch of configurations, and then each mode will have a bunch of sensor configurations, and putting all those all together can create a god-awful giant file. So this is the cruise definition file for the test setup, where we start up, we have the definition of the different loggers and what configurations each one has. And then we have the modes, which mode off has this logger in this configuration, no write has this logger. So that's already big. And then we actually get down to the configurations themselves. Mm. So for the P code writing both to the network and to the file, this is for defining an entire logger that transforms and sends data to different places. This is still fairly concise, but the fact is that you've got like 80 of these. So the file, how big is this file? It's over, it's well over 1,000 lines. 1,500 lines. So being able to bring the size of that down is a great boon. Let's see, going back to the presentation. Okay, here we are. So basically, what Ella and Steph did was use Jinja to allow you to template things for, you can see, for device and devices, for each device, these are the configs, and that expands out. And that's amazing. Thank you. I owe you the beverages of your choice. Next recent innovation is this SQLite API. Now, the original API was Django based, and with Django is fairly heavyweight. It wants to be your database and your web server and your front end, and that's a lot of buy-in there. So instead of using Django as the database, what Kevin did was ported things to have an SQLite database. So all you have to do is read and write from an SQLite database, and you can do all of the OpenRVDAS controlling that way. Opens a lot of things up. And let's see, what were the other things? Yep. Those were the those were the features worth talking about. Two things I'd love to spend the rest of the time on are, first, what's breaking, and second, where I think we'd like to go with OpenRVDAS. And I've telegraphed part of that in the earlier session. but let's do it like this. I'm going to first go over what I think is breaking, and then I'd like to open it up for other folks to tell me where they're getting hung up. Okay. Number one, creation of cruises is still kind of clunky. The Django GUI is still not great. And we have, there's great documentation for individual chunks of it on the OpenRVDAS in the GitHub repository. But that is, those are sort of individual, how you do this, how you do this. And what I'd really love to have is a complete documentation suite, tutorials, welcome to OpenRVDAS, videos, I don't know, and also cookbooks of, here are, recipes for creating this or for doing this, because I keep finding people saying, again, this is one of these things we talked about earlier of reaching out and after beating your head against something, saying, I'm trying to find a way to do this. And I frequently am able to say, oh yeah, there's a really easy way to do this. Bang, there's your 3-line configuration. Here's this transform you didn't know about. And so having a more complete tutorials and cookbook for that. So let's see, yeah. So what problems are people who are banging their heads against OpenRVDAS? What are you coming up against?
So probably the people most relevant to the Australian Antarctic Division are probably not around to answer it, but I would say that I think based on what you talked about, I think templating was an issue, but I do think that this the new Jinja thing that you presented may go a long way to addressing that. I think your mention of documentation is good as well. I think certainly everybody within our organization recognizes the power and also the flexibility. I talked earlier on about sort of a triangle. You've got power and flexibility. If we can make it easier to use, I think that's the third part of it. And Influx and Grafana are one way towards that, but it's sort of taking those mature processes and distilling them down. Again, I'll try and canvas from the rest of the team, but that's my intuitive sense of it. But out of the other groups that are working, do you have thoughts that you'd like to offer? Now's the time. So again, I'll turn over to my CSIRO colleague.
Yeah, I think our biggest sticking point was the Django GUI. So I think we'll be really interested in trying the new one, fresh off the press. But yeah, I mean, we found actually that everything else has been really great. It's worked really well. We've just started using True Winds and some other transforms like that, and we've implemented a few of our own as well, and that's all gone well. It's been really good. So yeah, I don't really have any complaints other than the Django GUI.
Yeah. And I'll also add, you talked about having the various transformers. I think it's good to be able to have that option of, you've got your internal transformers, and you can use Grafana and Influx, whichever you want to use. So I think that it's good to be able to have that power and have that flexibility to mix and match in those particular ways.
Sure, yeah, and I'll echo that on the transforms, because data where you want to correct it on the fly and have that written to file and rely on it after the database, but have it be effectively like, this is a corrected version of the data that we believe to be like base, that it feels like it belongs there in RVDAS versus some other different types of analysis that you would do later on. It's been good. I'm definitely still learning it and have leaned heavily on web, I will say, for it. But I think that the configuration file has been definitely like a big question. It's just been huge. But I think we're getting there. It sounds like as a group moving forward on that. I think, and again, I think this is coming up in all of our discussions is a larger question of, do we make things more user friendly for people that aren't so software enabled, or do we keep it strongly for this flexibility of needing to be able to understand how to configure it properly or not? And that's something that we're struggling with, but I feel like I have to answer that question for our organization first before I come to you and say, oh, we need it to be more of a GUI versus we can just deal with the coding piece ourselves. But having, potentially having the ability, and maybe the SQLite JavaScript version will deal with this, having some capability to make maybe sub modules be more flexible for marine technicians to easily deal with, as opposed to having to go in and write a configuration file, for example. But where exactly that all falls, I think is a pretty big question.
Mm-hmm. Now, I also don't want this to turn into just sort of the Australian corner talking, and I realize that we're the ones that have been working with it in practice, but from the rest of the people in the room, I guess, does what you see look interesting? Do you foresee challenges associated with implementing something like this? What would make you either decide to pick it up or be reluctant to pick it up? Any thoughts from anybody? None?
Yeah.
Well, this is Jonathan. This is Webb.
Hey, Webb.
So as somebody who's and Pablo's been there a lot of the times as well, but as somebody who has introduced OpenRVDAS to a number of ships, because in the last 2 years, between Pablo and I, we've deployed OpenRVDAS on over half a dozen 250-foot plus vessels. So you're full on global class, very complicated platforms, and it's pretty daunting when you say it's very simple. You just have to set up this configuration file, and then you lay out a 4,000 line configuration file. The more you dig into it, the more comfortable you do, the more sense it makes. But that initial learning curve is pretty steep, and with a system that is as powerful and as flexible as OpenRVDAS, I think having well-defined recipes, the cookbook that Pablo alluded to, I think that will go a long way to kind of help people feel more comfortable dipping their toe into this. I know Karina and I, because I, kind of said, it's like, yeah, no, you just do it like this, and then she's like, whoa, back up. And because to me, I looked at it and I was like, oh yeah, that makes total sense. But the learning curve is a little steep, but once you get through that, it does actually make sense. And I think, like in that particular case with Karina and I working together, I did spend time and actually document, a start to finish. Here's how you set up a logger. And I think that went a long way for both of us, for me to actually organize in my head how it worked, but then also kind of to lay it out. It's like now all of a sudden, when you start to look at it in these little individual blocks, as opposed to just looking at it, in its entirety, it does it does make a lot more sense. So I think, to Pablo's point about better documentation, cookbooks, recipes, best practices, I think that'll go a real long ways to help people feel more comfortable getting into it. Because you really can do, in terms of logging, there's not much that I've found that it can't do. And we've done some really fun stuff on Falcor 2 with the real-time corrections, leveraging the GSW, the TALS 10 Python library. for doing real-time corrections, depth corrections, oxygen, etc. On Ocean X, we actually wrote a transform that actually parses raw ADCP ensembles to build a Grafana dashboard that actually shows you, surface currents for setting up the ship and preparing an ROV team for launching a vehicle. So all that's been possible without any updates to the code base. It's just a matter of understanding how the logger works and being comfortable. Once you're comfortable and you start to dive in, there's really not much it can't do in terms of being able to move ones and zeros where you want them. Yep, good.
I was just going to say it's absolutely undeniable that the power and flexibility are there, and I would also agree that with documentation is a sure sign of maturity in a product as well, because it says, look, we've got something that makes sense, that's stable, and you start adding the documentation, you start adding the examples. I think that it's probably maturing in a fairly standard pattern.
The one thing, and Pablo, you and I have already talked about this. This is going to come as a surprise to you, but just for the rest of the group, a simple tool to verify the schema prior to pushing it live, I think would be amazing. To basically have something that does it does a basic YAML syntax check, of course, but also goes so as far as like, hey, you've set in your mode to run this config for this logger. I can't find that config. So just like a tool to actually verify that the logger YAML file is schema complete. Apache, things like Apache and like Nginx, they have similar utilities for verifying the config file prior to deployment to live. And so I think if there was a tool that could parse the YAML, look at the resulting object, verify all the pieces are in place, I think would be an incredibly useful tool for those of us that are still doing a lot of hand modifications because we're trying to do some pretty exotic setups.
Right, and actually, Kevin's SQLite GUI does have a rudimentary, it's a YAML lint that gets called when you load the file. But that's already your, I guess it's calling a Python module of YAML lint. So it's not doing the more semantic analysis that would be helpful of, let's say, missing configuration or, modes not defined. But that's definitely a hook to get that done.
Is that what you were thinking about, Nils?
No, I think there exists software to check YAMLs, the same as for JSON files. So you can define a structure that the YAML needs to comply to. You can add different options, for example, for one key that there are 10 possible answers, but not anything else. So there exists some rudimentary checks for that. But we need to do the effort first to define the possible schemas. So
there may be some tooling to do that.
Yeah.
Yeah. Okay. That's a good point.
There is, to be clear, there is documentation. It's just not as sophisticated as, let's see. So I'm going to go back to, I'm going to hijack the screen here again.
Yep.
So just in the, come on, Zoom, we don't need you there. So inside the docs directory for on the repo, there's plenty of documentation on the pieces of it, but there's not like a unified, it all really needs to be pulled together into, I don't know, something that's more findable and more complete. And stop share.
I will say the inline documentation, if you start digging through the code, Pablo has done an amazing job on the inline documentation. So if you want to know how a particular module works and you're digging in the code, the inline code documentation is fantastic. And
Thank
that's
you.
often when, yeah, absolutely. I was quite embarrassed with my own code after reading yours. And, but that's usually my go-to. Like if it's not a runtime issue because I've got a bad YAML config, that is my go-to for understanding OpenRVDAS, is to just go straight to the repository, and the files are reasonably well named. They kind of say what they do. And from there, I just dig into, and you've got really great inline documentation that goes through what the various variables for a function call, what they actually mean. It's a great place to start for anybody that's just kind of getting into it.
All right. Any other questions regarding sort of things that you would want to see from OpenRVDAS? Going.
I think I've
All right,
definitely got my marching orders here, and I don't recall who it was who said that they're really eager to try the SQLite GUI. It's still very rudimentary. It's basically it's the what's the thing when you're trying to build a bridge and you send the first little line across. It's the first line across that we're going to be able to pull a much better GUI over. But better GUI is going to be a big thing for me still. So let's see what. And trying to find, going to go back to the presentation and window. Nope. Thank you for putting up with my. Okay, here we go. So roadmap, this, the places where I want to take it. First of all, is no surprise here. I've kind of stacked the, stacked the conversation. Improved documentation, simplified configuration, more robust GUI, and what we talked about earlier, solution for long-term project support. So, we talked about this a little bit. A better website, tutorials, cookbook. I was just somebody I heard sideways from that, the NSF, somebody high up at the NSF was looking at, moving more of the ships over onto OpenRVDAS, and he apparently went on to the OpenRVDAS Ocean Data Tools website and said, it kind of looks like amateur hour there. We sure we want to be putting our ship's data on that? So
he has no idea what's currently on his ships.
Yes, that's right. Exactly. Yes. But I think having a more professional, outward-facing look, this is what's going on, would soothe some worries at the level of the people who fund all of us. Next, improved cruise configuration. Jinja-based templates are an amazing start. Way back when, I was sure that fairly soon we'd have a graphical tool for sort of dragging and dropping. And an undergrad at Stony Brook started working on that and decided it was much too hard. And he decided he'd rather graduate. And so, but this is, I don't know what that would look like. Finally, a more robust GUI. The Django GUI was written by me. I'm a software architect. I'm a software engineer. I'm not a user interface designer. So I think this Dilbert's strip is fairly apt. And then finally, so the current support, as we talked about earlier, it's, Webb and I are doing this, partially on our own times. A lot of the work comes from individual contracts, when Webb goes aboard Falcor, or I'm on one of the USAP ships or on Ocean Explorer, they want certain functionality. And so so a lot of the improvements get funded sort of on the side by that. But other than those individual contracts, the ongoing maintenance is pretty much, it's a labor of love of, two guys in a barn or two separate barns or what have you. And one of the things I've been asking around is, does it make sense for this Ocean Data Tools suite to become affiliated or with some, physical institution, and, be adopted. And I don't know, that comes with, the strings provide support, but they also hamper where you can take things. And that's,
And it also adds overhead.
Yes.
It adds, I mean, and depending on which institution you go to, there are some institutions that, any funding that comes in, they will take 50 cents or more for every dollar that comes in. And so then, less money is going towards the project. Other institutions are saying, well, why are we doing this? Like, our money isn't going to the things that we need. So yeah, I mean, there's definitely, there's big pros and cons. And you can't tell, Pablo and I have looked into parenting with, and we just haven't found the obvious solution to this problem.
Yeah. I mean, there was some murmuring about trying to fly in formation with the R2R folks. So basically it would be S to R to R, sensor to rolling deck to repository. But that's they've got their hands full with what they're doing, and that's sort of like we're trying to put out the fire on our own ship right now. We can't go over and help you. So, sorry.
Hi, can you hear me? This is Pamela Fletcher.
Yes. Hi, Pamela.
Hi. So I'm down in Nicaragua, Central America, working with sea turtles right now, and I'm probably one of the unlikely participants in this Polar Data Forum, but I sat in a NOAA laboratory for 12 years as a Sea Grant laboratory liaison. I'm not sure how many of you are familiar with Sea Grant, but it's an outreach education extension arm of NOAA. Are you all familiar with NOAA?
Yeah.
I can see the room, yeah, it's bobbing around. But one of my major tasks was to be that boundary organization between data end users, whether they were programmers or a decision maker, and the amazing researchers that I'm picking up, like yourselves, who have the programs that run the sensor software behind the scenes. And what a team of us did for about 20 years was try to really ask our end user community what it is that they need. We chose decision makers because at the end of the day, those were the people either controlling purse strings or had the greatest interest in the data sets. And a few of the ideas that came out of lessons learned from our coral reef monitoring project in the Caribbean was that, number one, grant proposals, when written, should probably have a percentage that goes to some of the things. I think, was it Webb, you had just said, like, who has the resources for that? But to help somebody be that conduit for interfacing from this amazing data set to the end users at multiple formats. I mean, the other thing that I did a lot of was met with the sensor designers and tried to understand how those are either built, programmed, and the interface, and spent many, many hours working with people who would use the data sets. So I can't say we achieved great success, but those are two recommendations from 20 years of trying to help take these large data sets and put the information in a usable format to a bunch of end users. I have literature, I have presentations and things from other conferences that I can share with you if you're interested. I just need to get those from another computer, but happy to discuss offline or answer questions if anybody has some questions.
Oh, that sounds, thank you. That's a lot to digest.
Yeah, I don't know how long I'll be on, but it's the interfacing.
Yes.
That actually, I mean, as far as familiar with NOAA, I mean, as I said, I worked for the Office of Ocean Exploration and Research for 7 years, and yeah, so I'm very familiar with NOAA. That I mentioned in the last session about, from an organizational structure, is there a way to better organize what Pablo and I have started to facilitate investment from outside groups, and that's kind of dovetails exactly into what you're saying. Is there are certain criteria that groups have to meet to be able to apply for, and I'm speaking specifically US, to be able to apply for grants. And, you know, does it make sense for us to organize ourselves in a way that does allow us to be able to go after grants to get base level funding to allow us to mature the project and improve its documentation, improve its support, grow the team, get out of this single point of failure mentality. And can we, you know, in a way, can we, you know, stone soup it? I don't know if everybody's familiar with the stone soup parable, or where, you know, everybody contributes a little and you get something great in the end. I think that's an interesting avenue to pursue, and that's something Karine can speak to it, as we've talked about it, and with other with OceanX, I've talked about it in other groups about you know, trying to formalize a model to provide baseline support so that it isn't just Pablo and I, so that we can bring on additional personnel either from within this group, from the user group that can provide you know, like the work that was done with the Ginger and the SQL. Can we, you know, extend more formal invitations for them to contribute, you know, to be able to get more of their time to you know, help us, you know, flesh out this project and get some greater support, or, you know, hire, you know, dedicated, actually go out and hire dedicated personnel to help support this, either in a full-time or part-time capacity.
But, whoop. Anything else from online? No, because one thing that I will say is that at some level, the work will need to be done and the resources need to be spent on doing this. This is something that we require in some form or another. So we can spend time pursuing independent solutions that has its own benefits in terms of flexibility, but there are also inefficiencies in terms of you know, thought has gone in, hard lessons have been learned. So we may want to think about, you know, do these systems provide value to us? And as Webb was talking about earlier with community, if they're not providing value to us, then we should be able to articulate why that is. Why aren't they? Aren't these systems providing value to us, and what needs to be changed in order to improve them? And we heard, you know, the developers are willing to hear from us. So, you know, this is part of the notion of knitting together community in order to support them. But I would say it's not, you know, there isn't going to be any form of police telling people what to do. But if the community solutions aren't meeting needs, then we do need to think about why that is and try and communicate it back. Any other thoughts from online? Do we still have Pablo and Webb there?
Yep, still here.
Yep.
And
Okay.
yes, sending, I guess my camera is off, but I'm giving you a thumbs up here.
Okay, thanks.
Just on a technical question.
Yep.
It would be useful to have more information about the ADCP transform. As in getting that into useful data.
Yeah, that was something I wrote for OceanX. That I can absolutely, I can see if I can get clearance to get that code out. But basically, I mean, it was very, again, it's a great architecture with OpenRVDAS. It was as simple as configuring the ADCPs to send the ensembles via UDP port to OpenRVDAS and writing a transform that could deal with the multi-line ensemble, that could parse that ensemble correctly into its vectors, and then coming up with a way to logically insert that into influx, so that it was very easy to pick out, okay, these are my U and my V vectors for this given depth bin. And once we got all that sorted out, then it was simply a matter of using a Compass Rose widget in Grafana and hooking it up to the corresponding vector bin that we wanted to visualize, and then just building a dashboard that all it showed were the vector bins for the given depths on the two ADCPs. It took a bit of head scratching to figure out how to architect it all, but once we did, implementing it was incredibly straightforward because of the architecture Pablo's come up with. But I can absolutely reach out to the folks at OceanX and see if they're amenable to open sourcing that. And if they're not, then I can absolutely probably re-engineer it again. That's not a big problem.
Just to be clear, was that Python transform from the UDP out from the.
It was
ADCP?
yes, it was written in Python. It was written as a proper OpenRVDAS transform. So it was a straight plugin. As Pablo went through that configuration file that had the readers, the transforms, and the writers, it was in the transform category. So I wrote the transform using the syntax or the architecture that you use for writing OpenRVDAS transforms, and it just sucked in that multi-line ensemble, and it spit out a Python dictionary that could be passed downstream to our InfluxDB writer.
I've got a naive question for both of you. I haven't looked at. Do you have tickets that could be ticket requests that could be submitted, but also picked up by developers in the community? So, say for instance, if there were an ADCP transform that somebody wanted written, could they post that as a ticket that somebody could say, yeah, I could pick that up and write that?
Yeah, absolutely. So yeah, on the repositories, with the, you can post feature requests or bug bug reports, and that's on the GitHub. Let me go to. Let's see if I can hijack the Zoom again. In desktop. And so
there it is.
Yep. And so you can say, what are issues that people have reported? And most of them are reported by me or Web. Here's another, that's Mike. And then up here, there's also, and this is, he's issued a feature request, and he's taken the feature, and he's now submitted his changes he would like to have pulled back into the repo. And once I'm off here, and once I've had my nap, I'm going to do a code review and pull that in.
Yeah, so that's a good example of, this is how you can start to build that community. If there's something that you'd like to see, submit it as a request. And if it's something that you would, if you're really keen on it, then try and implement it, or try and implement other things if you think that they're easy. But this is how you would build it up.
Yeah. Open source for the win.
Right.
Yep.
And Pablo and I are also completely on board, and there was links to, I think, in both of our presentations. We do run a Discord server, so we had a Slack server at one point, but we weren't seeing a lot of traction there. But we're we're more than happy to go through the formal change request bug report format, but we're also available for more real-time communication. We're currently trying Discord over Slack.
Apparently, all of
it's,
the cool kids. Apparently, all of the cool
right.
kids use Discord.
Exactly. Yeah, exactly. All the gamers in the group, hardcore gamers in the group. But Discord, it's got great VoIP capability. You can do point to point. You can set up groups. You can do screen sharing. It's easy to do attachments and all those things we've come to expect from most modern chat capabilities. But we've actually paid for that service, and so you can search it. You can submit. We can have discussions on there that you can go back and search. So whatever. Again, the greatest tool is the one that gets used, and so we're trying to put out as many ways for users to get in touch with us to tell us what doesn't work, what could be improved, what would be great to have, and whether that's through submitting a trouble ticket or starting a real-time conversation, like we're on board.
Great. So you did bring up the notion of resourcing. I think that that's a fair question to ask. Pamela, it sounds like Pamela had some ideas as well, but I'll bring up the same thing that I said to Webb at the end of his presentation, and that's there are things that we can ask of you, but what would you ask of the community?
Ooh, good question. I know. Let us know if you're for OpenRVDAS at least. Let me know if you are using it, and if you have questions, keep me apprised, because the more data points I get on problems people are having. First of all, if you're having a problem, let me know, and I'll do what I can to help talk you through it. And I am shameless about I like riding on ships, so if you can get an awful lot of work done if you offer me a 1 week transit on whatever ship you've got.
Transit bribery works. We'll keep that as a note.
Especially if you're going somewhere fun.
Yeah, excellent. Well, we have that in the transcript now. Any other thoughts from the floor? Again, now's the time to ask. But if not, then yeah, Alex.
Briefing, possibly related to some of the stuff about the GUI interface for starting and stopping sensors. One thing I've been tracking on, and you probably have already seen it, those guys online, in Grafana, they have a new Canvas panel in there. I mean, I know we all use Grafana. No matter what our data logging system, virtually everyone uses Grafana for visualization. The new Canvas panel does have the start of actuator buttons, so buttons that actually will do something we'll call APIs. So you do have the ability there to both visualize your data and the ability to call an API that may stop or start a sensor. I just throw that out there. They're just starting, but the Canvas panel is obviously something they're working on fairly hard in Grafana, because obviously it gets them into a different space from just visualization. That gets them into all sorts of industrial processes if you can actually do things with it rather than just view.
That would be great. Actually, and you've reminded me, in terms of folding new functionality in, I'd love to ask folks, I try to avoid feature creep. I'm trying to draw OpenRVDAS back to, not being the Swiss Army knife, but there was some discussion at RVTech of a feature that some people would like, which is, I'll call it data dependent modes. So this is basically geofencing is the obvious application, where Antarctic program wants to switch on logging as soon as they leave the Argentine EEZ. And right now, what that basically means is I or whoever's on board is sitting there watching lat and long click off, usually at like 3 a.m. Tick, tick, tick. Okay, we're outside the EEZ. Now we're going to click and shift the mode. It would be not terribly hard to create a transform that is, let's say, call it a geofence transform, where you hand it a lat and long, and it tells you whether you're inside or outside the fence, and that transform into what I will call a logger manager writer, which would basically you could send messages saying, switch the mode to underway, switch the mode to off. So you could have the system automatically change its logging dependent on the data it's reading.
So interestingly enough, we actually use a similar approach with C-Log, with the whole data-driven control.
Yeah,
I think you're on the right path. The way what you were saying was exactly what I was engineering. Is if OpenRVDAS essentially had a control API, meaning go to this URL with these parameters, and OpenRVDAS will do something. Switch modes, for instance, is probably the most logical example.
Right.
Then when your geofencing transform, whatever threshold it has to cross to flip the switch, then its response is to issue an HTTP request. I think that would potentially solve the geofencing thing. But circling back to what the gentleman said about, and I apologize. So you guys are very, very small. But I think if that functionality was in OpenRVDAS, if there was a more fleshed out control API to OpenRVDAS, then that would open up the avenue to basically put that button on Grafana that calls the OpenRVDAS API call to do a thing. In C-Log, we do this actually quite often in both directions. Like, for instance, in some cases, we've got C-Log actually turning on video recorders because both C-Log and the video recorder have a reasonably fleshed out REST API. So I think something similar probably actually that's an interesting idea. Is there a way to enable a API control of OpenRVDAS outside of command line, outside of Django or some other web UI?
Yeah. Okay. Good.
To the original question, though, I think geofencing was well within scope of a marine data logging system. I think if that was the original question, I mean, the SAS has a rudimentary geofencing option within it. It's a data logging system. I think I would say that is well part of whatever data logging system you're designing.
Okay. Got it. The pushback I'd gotten against it is, some folks said I wouldn't want to trust a international diplomatic incident to your code. It's like, okay, my response to that is, okay, you don't have to use it, but there are folks who would. So, okay, I wanted to validate there are folks who would, and it sounds like there are folks who would.
But
There's social engineering,
Pablo, because then that transform can be applied at a pretty low granular level, because there are certain loggers that can be logged all the time. There are certain loggers that can't. And by setting it up as a transform, you're not adding a baseline bloat to the code. It's just this optional module that's applied on a per logger basis.
Right.
And there's also social engineering associated with that. You use the boundaries that are approved, and if you want to have precaution, then you can buffer. So I would say in your case, this is the tool. It's not your responsibility. You're not responsible for how people use it or how people interpret it. You're just providing a capability.
Right.
Yeah.
Right. There's yeah, and actually I've forgotten what the name of the tool is. GeoPandas. There's a lovely Python module that allows you to pull in a massive number of online EEZs and then compute distance to the boundary inside or outside, and you can add the buffer to a buffer to the outline. So it's a very powerful library. Should be fairly easy to write both of those modules.
Yep.
Well, okay. Thanks. Let's see, looks like we've got 15 minutes left in the day.
Yep. I'm just going to canvas. Do we have any remaining questions? Otherwise, I don't mind letting our guests off the hook. It's been a long day as is. So I will give the opportunity, or in reverse, if there's anybody online who wants to ask, but I'll say going.
The one, sorry, and I apologize. I know everybody
Yep.
wants to go.
No.
For anybody that's got any questions, and Pablo highlighted this, and I fully supported about, outsource what you can to industry provided solutions that do have a deep bench, things like Influx and Grafana. Kareem's done an amazing job with doing some really fun stuff with Influx and with Grafana to implement a lot of functionality that I think anybody that's doing this job would really appreciate, in terms of things like dead man switches, real-time QA, being able to condense the ship's worth of data streams into a single waterfall plot that provides a quick glance as to what's running within spec, and what's not running. So I think if anybody, and sorry, I'm sorry if I just filled up your evening, Kareem, but but if there is an incredible amount that can be pushed downstream to these enterprise tools for doing all the things we really want to be doing, like the real-time QA, like quick snapshot ways for text to take a glance at a screen and know big picture health of the ship. She's done a lot of really, really cool work on Falcor. Alerting, using Influx and Grafana's alert mechanism and its integration with Slack. Lot of cool things that you've been working on with Falcor, and that's just what I know of. Like we haven't met, me and many of the people in the room. I'm sure everybody I talk to has usually done something I haven't done that I'm envious of. So I'm sure there's other people in the room, but I know at least I know Falcor, and so I would, if you have any questions about that, I would ask her, because she's done some really, really cool stuff that I've scratched my head for years on how to do, and it's very easy using these tools that were never written for our world, but are applicable. So other than that, if we're all departing, I just really appreciate this community reaching out to myself to come participate. This has been said multiple times. This is really just a passion project for me. I just really enjoy this stuff, and I enjoy hearing about people using my stuff. I do enjoy hearing that what I did allowed them to get an extra sleep at night on a ship. So thanks again so much for letting me be a part of this.
Likewise.
And likewise. Oh, go ahead, David.
Oh, I was just going to echo what Webb said. This is a for my part, this all started because when I was working on the Nathaniel B. Palmer, and first time I fired its data acquisition system, which, as I said, was C wrapped in Perl, wrapped in Bash, and my eyes bled, and from there it's become just it seems like it's a chance to do good in the world. So thank you for helping make that worthwhile.
Well, much appreciated. And from our part, on our side, thank you. I mean, it's an impressive amount of work. And also, I know that this immediate discussion started because I was talking with Peter and Tess, and they said, oh, we should try and get Webb and David to talk. And I put it in a list, which somehow got circulated by email. And I think it was either, well, one of the two of you said, we said we were going to do what? But then you actually came and joined. So it worked out in the end. So
Yeah,
again,
just
thank
like-
you
it's just
for
like going
your
to sea.
partic-
Yep.
What was that?
It's just like going to C. I was brought out to do A. I ended up doing A through C. So it's just like going
That's
to C.
exactly it. But yeah, we'll leave it at that. Thank you so much for joining us. Much appreciated. A lot of information, a lot to think about, and at the least, everybody now has much greater exposure, much greater understanding, and we know that we're all available to talk with one another. So thank you again. Have a good night.
Cheers.
So I'll just end up by saying this doesn't help anybody online, but Ria has brought with some very nice microfiber cloths for lens cleaning from the South African program, as well as some stickers. So if you'd like to take them from up front, we'll keep them. We'll probably try distributing them later on today. I'll also say thank you for your participation. It was a full day. I hope that you've got something out of this and that you found it enjoyable. We will be continuing tomorrow with some greater in-depth topics, but this is what I wanted it to be, which is a table conversation, getting everybody on the same page and discussing